Hi everybody, today I'm going to be talking about the mathematics of Bitcoin and the idea behind it, known as blockchain. Hopefully by the end you'll have some understanding of how it all works, even if it doesn't make you instantly rich. Many people have dreamed of becoming cryptocurrency millionaires, and for a few the dream has come true. When Bitcoin started out, their value was close to zero, and only a handful were smart or reckless enough to get involved. But by the start of December 2017, the value of a Bitcoin had shot up to about $10,000, and by the 17th of that month it rose to almost $20,000, having doubled its value in just over 2 weeks. Plenty of people jumped onto the Bitcoin bandwagon. Many of them were disappointed and some lost a lot of money. A few days after reaching its maximum, the Bitcoin value dropped almost 20%, and as I speak it's around $8,000. Of course, that's a pretty good return on investment if you bought when the value was next to nothing. The origin of Bitcoin lies in a document published in 2009 in a cryptography forum by a programmer whose nickname was Satoshi Nakamoto. There's a link to this article in the description of this video. Transactions in this new type of currency are carried out directly between users, with no bank or other organization involved. The value of the Bitcoin is determined solely by supply and demand. So how does it work? First, to use Bitcoins, you have to install a wallet on a computer, mobile phone or tablet. As soon as you do this, your first Bitcoin address is generated, and this enables you to pay for Bitcoins or receive them. Each Bitcoin address should only be used in one transaction. All transactions need to be verified. They usually take about 10 minutes, although this can be reduced by paying a commission. The waiting time and the payment of a commission prevent malicious users from clogging up the system with a massive number of requests. All Bitcoin operations are recorded in what's called a blockchain, which is a public record of all transactions. The important thing is the identities of everyone taking part are kept secret. This secrecy is vital to Bitcoin and depends on applying cryptography, which in turn depends on mathematics. In the world of Bitcoin, everything we've talked about so far is called mining. It involves a huge amount of computation. In the past, some people chose to let their own computers be used for mining in exchange for paying part of their commission. But that's no longer profitable, and computer farms have been set up to do all of the necessary calculations. Bitcoins can be used like any dealings with foreign currency or stocks and shares as a means of speculation, buying and selling at the right prices to make a profit. But there have also been reports of cryptocurrencies being used for money laundering and also fraud. As in all cases where money is involved, you need to be careful. At the heart of Bitcoin technology, as I've mentioned, is the blockchain. It's a concept that promises to be useful in many different areas, including business, health, and industry. The key to the blockchain is maths, from database entries, which can be seen as matrices, to the cryptographic tools that are brought to bear. To understand the blockchain, we need to know a bit about cryptography. Remember when you were young and sent secret messages to a friend by changing each letter into the next, A into B, B into C, and so on? No? Maybe it was just me. Anyway, that would involve just a very simple cryptographic rule or set of rules known as an algorithm. There are lots of different cryptographic algorithms, and if you're interested in them, just leave a comment and we'll do a future video on them. Many cryptographic algorithms are based on maths processes that are easy to compute in one direction but hard to invert. One of the commonest of these processes is factorization. It's used in a well-known cryptographic algorithm called RSA that's the basis of all our online banking and credit card transactions. Cryptography involving factorization stems from the idea that if you have two prime numbers, P and Q, it's easy to work out their product, N, equal to P times Q. But if both the primes are very large, then it's extremely hard to work out what they are if you're only given their product. For example, if n equals 6, we can quickly see that 6 equals 2 times 3. But if n equal to p times q is a large number with certain properties, then it's almost impossible to work out the values of the primes p and q. What cryptographic algorithm is used in the case of the blockchain? It turns out that it involves something called elliptic curves. So now we need to look at what these curves are. An elliptic curve is a set of points x, y that satisfies the equation y squared equals x cubed plus ax plus b for certain values a and b, together with a point O, which is called the point at infinity. Now, the elliptic curve used for the blockchain is the specific one for which a equals 0 and b equals 7. In other words, y squared equals x cubed plus 7. To calculate points on this curve, you just put in values of x and figure out the corresponding value or values of y. For example, when x equals 0, the equation becomes y squared equals 0 cubed plus 7, or y squared equals 0 plus 7, which is 7. Taking the square root of both sides, y equals the positive or negative root 7. This gives us 2 points on our elliptic curve, 0 square root of 7 and 0 negative square root 7. And we can carry on finding many more points to produce a graph like the one shown here. For any elliptic curve, we can define a sum operation. This isn't like ordinary addition, but is a way of combining 2 points that's known as point addition. Say we have 2 points, P and Q, which lie on the elliptic curve, like those shown on the screen. What's their sum? We draw the line that joins these 2 points and extend it until it intersects the curve at a third point. Then we find the point that is symmetrical to this in the x-axis. This is what we refer to as the sum of P and Q, P plus Q. Let's repeat the process with these 2 points. Extend the line that joins the 2 points until it intersects with the curve at a third point. Again, find the symmetrical point, and this represents the sum P plus Q. We can also use the curve to add P to itself to give P plus P, or 2P. To do this, we consider the tangent line to the curve at P and extend this line until it intersects the curve at another point. The point that is symmetrical to this with respect to the x-axis is 2P. Just rewind the video if you want to see these examples again. The elliptic curve with this operation that we've been looking at satisfies some important properties. the associative property, the existence of a neutral element and a point at infinity, and the existence